In this video I'm going to talk to you about arc length and the area of a sector. So firstly, let's just understand what a sector is. There are two types of sectors, and they're within a circle. You can get the minor sector, which is made from this angle, and this is a major sector, which is made of obviously a reflex angle. It doesn't matter what kind of sector you're dealing with, the formulas for the length and the area are exactly the same. They just depend on the angle theta. So let's just go with a minor sector because that's the most common one. So, let's just talk about how we find the formula for the arc length. So the arc length is a fraction of a whole circle's circumference. The fraction of the whole circle is actually theta out of 360 degrees. So if we go with L, the length, we've got theta over 360 multiplied by the formula for the circumference is 2 pi r. Now if I simplify that, I can obviously cancel that down because it's 1 over 180. I end up getting theta pi r over 180. Now that's perfectly fine if theta's in degrees, but what we do know is that pi upon 180 degrees, hang on, how can I write that? Pi over 180 degrees is actually worth, in radians, is actually worth 1 degree. So if I use that and substitute this in here, I'm actually left with, take that away, sorry, sub that in, take that out, we're left with the arc length being just r theta or theta r. It's usually written r theta to be honest, and that gives you the formula to work out the arc length in radians. So now I've cleared some space, let's have a look at the area formula. So we know that the area of a circle is pi r squared, and of course we're just dealing with this particular fraction in degrees out of 360, so it's theta divided by 360 gives us the fraction of the whole area of the circle that we need to find. Now if theta is in degrees, of course we're going to use this formula. But let's have a look at what happens if it's in radians. So I'm going to use this relationship here, pi over 180 is 1 degree, and if I look at this, this can be separated into theta pi r squared over 2 lots of 180. And then that way I can then substitute that for 1 degree, and I end up getting 1/2 theta r squared. And that gives you the general formula in radians to work out the area of a sector. Alright, so here we're going to find the arc length and the area of the given sector. So we see here that the angle given is in radians, just looking at this. Obviously it's in pi, so it gives the clue away, but there's the radian sign there too. We've also got the radius as 10 centimetres, which is the same equal length of this side of the sector. So let's first start off with the arc length. As we're in radians, I'm going to just use the formula r theta. So the length, and we are dealing with a length in centimetres because the radius is given in centimetres. So I'm going to go the radius 10 multiplied by 2 pi upon 3. 10 times the 2 is 20, so I'm left with 20 pi upon 3, and of course the units in centimetres. Now you could work that out, or you could leave it as an exact value. I'm going to leave it as an exact value. Now let's do the area. So area, again, remind yourself of the formula. The area is 1/2 theta r squared. Okay? Now, let's work out what, by substituting the values in, I've got 1/2 multiplied by 2 pi upon 3 multiplied by 10 squared. Okay, now obviously the numerator is there, that's on the numerator, so it's 10 over 1. Multiplying everything together gives me 2 times 10 squared, that's 200 pi over 6. Now that cancels down to be 100 pi over 3, and our units are in centimetres squared. And that's pretty much everything you need to know about the area and